What is up, math magicians? This is section 2.5, solving systems of equations algebraically. And we're going to do it over the course of 2 days. So today, the first day is substitution. Yesterday, or the previous video, was doing the same thing graphically, but now we're going to accomplish the same goal with only algebra. Let me show you what I mean. Food truck. Andrew sold a total of 240 hamburgers and cheeseburgers. Coincidentally, she estimates that she sold twice as many cheeseburgers as hamburgers. How many of each does she estimate she sold? This is something we could graph if we wanted to with yesterday's techniques. We could line them up on a graph, create two equations, graph them, find the intersection, and that would be the answer. We're going to do it without a graph today. It's going to be incredibly important that we write our unknowns and our knowns because because we have to examine, we have to create equations. We have to figure out how these equations work with each other. So what don't we know? And what don't we know is always found by looking at the question mark right here. How many of each does she estimate she sold? Each what? How many of each, like hamburgers and cheeseburgers. So our unknowns are H, hamburgers, and C, cheeseburgers. Great. Write it out. Acquired. Great idea. Studentship. Knowns. It's going to be really common thing in these word problems that there's often just a total number of things that are sold or purchased. Find your total equations. What's the total here? The total is 240. Sandwiches total, and then the second thing that we know is that there's twice as many more cheeseburgers than hamburgers. If you wanted to, you can take these two knowns and in collaboration with the unknowns and say that H plus C is equal to 240. That's the total equation, and then 2H is also equal to C. Not 2C is equal to H. It's actually, I think it's kind of tricky to figure out which one of these is actually correct, because the incorrect version is very common, a studentship mistake. 2C equals H. But 2H is equal to C is correct. And the way I kind of think about it is that which one is larger, C or the H? So therefore, the C here, you have to multiply the smaller H times 2 to get the larger C. I hope that helps you. Anyway, here's the trickiest mathematical part going on right here. Recognizing that we have these two equations, I can actually take, and recognizing here that one of the variables is already all by itself, that's the C. What does C equal? It equals 2H. What does C equal? 2H. Say it. Say it out right now. Wherever you are, let me hear you. What does C equal? Right. C equals 2H. So therefore, we can rewrite the top equation, again, using a set of parentheses, H plus, and this used to be a C, but instead of writing a C, we're going to write what C is equal to. And what is C equal to? It's equal to 2H. So I keep on writing equals 240. Now, the brilliant thing about this technique is that all of a sudden, we have one equation with one unknown that you can solve. This becomes H plus 2H is 3H is equal to 240. And undoing the multiplication, you get H is equal to 80. That means you've got 80 hamburgers. Let's figure out how many cheeseburgers. You can take this 80 and plug it back into one of the original equations. Actually, it doesn't matter which one. I'm going to choose the blue one because it's a little bit easier. 2 times our answer right here, no longer H, but instead 80, and get C. C is now 160. And so now we're basically done all the calculations, which customary presents our answer sometimes in the form of an ordered point, and it's usually in alphabetical order. So this is H comma C, C comma H, alphabetical order, right? So so there it is. That's the technique. The core of the technique is right here. The technique is called substitution because you substitute 2H in for C in the other equation, blending the two together. Let's do this again. Bake sale. Cassandra and Alberto are selling pies for a fundraiser. Cassandra sold 3 small pies and 14 large pies for a total of $203. Alberto sold 11 small pies and 11 large pies for a total, you hear that word? Total of $220. Determine the cost of each pie. Great. So let's let's do the knowns and unknowns. Again, when you get to your Alex word problems today, or the next day in class, you're going to be required to write out the knowns and unknowns. And maybe if you're worried about like too much handwriting, you can just write a U and an N. Spelling a U and a K for unknown and knowns. So the things that we know, the things that we don't know are often easier to figure out. Like it says, determine the cost of each pie. That's what we have to find. We have to find the cost of each pie. Here's the cost of the small, and here's the cost of the big or the large. And the one thing that students forget to do the most, that blocks them, the single most common block that students have in creating equations is the fact that they don't choose, if they don't choose a letter from the alphabet to represent the thing that they don't know, then that will block you. It's impossible to write an equation, much less solve an equation. You can't even write the equation if you don't choose a letter from the alphabet. So y'all, listen to me when I say choose a letter from the alphabet. What I just say? That's right, choose a letter from the alphabet to represent the thing you don't know. So I'm going to say S is my choice here is S and the other choice is B. You could choose X and Y if you really wanted to. Let's see, what do we know? We got two different totals. Total of 203, write it here. Total of 220, write it here. And so then you can start pulling together the 3 and the 14. See, three smalls plus 14 bigs or larges. I guess I'm going to choose B for big because L is just, it looks too much like a 1. So 3S plus 14B is equal to $203. And then the cost of the smalls times 11 plus the cost of the larges, or big or larges, times 11 is equal to 220. That's Alberto. So now I've got these two equations. And I'm actually going to, one thing that made this technique possible over here was the fact that C was all by itself. It's going to be a little trickier because none of these variables are already all by themselves, but I can rearrange them. This Alberto's equation happens to be, you can divide all the terms on both sides by 11 and still keep the numbers relatively easy to work with. So you divide by 11, and all the terms on both sides divided by 11 gives you S plus B is equal to $20. And then you could choose either one you want to get all by itself. I just chose S to subtract from both sides and get B is equal to $20 minus S. Great. Now, let's take the other equation, the blue equation that we have, and instead of writing B, we're going to write inside a set of parentheses 20 minus S, because that's what B is equal to. And all of a sudden, you've got this blended equation that has only one variable, and we know how to solve them. You can distribute the 14. You can combine the like terms to get negative 11S, and so then it's 20 minus 11S. So it might be easier to visualize why you should subtract 280 first from both sides if you split this up, or think about this as 280 plus negative 11S. So then you undo that addition by subtracting 280 from both sides. Dividing both sides by negative 11, you get this, and then so S is equal to 7. The cost of a small is going to be $7. Putting that back into one of the original equations, we get, and I'm going to choose this one here, B is equal to $20 minus S. We get B is equal to $20 minus, what do we now what S to be? It's $7, which is 13. So that means B comma S would be 13 comma 7, the cost of either pies. Awesome. I think now might be a good time for me to talk about the audio check. Fun fact, Mr. Bergman was an Eagle Scout when he was in high school. So that might not be a surprise to you, but I had a lot of fun on the Scouts. And if you are in a similar situation, why don't you let me know? I had a great time. I had lots of friends, and I went to Philmont, and it was so much fun. So, boom, there's your audio check, Eagle Scout. Stocks. Miss Patel invested a total of $825 in 2 stocks. Stock market. All right. At the time of her investment, one share of stock A was valued at $12.41, and a share of stock B was valued at $8.62. She purchased a total of 79 shares. How many of each were purchased? All right, so again, Studentship, don't skip this step. It's incredibly important to write it out and think about what you know and what you don't know. So the unknowns, to start off with a question: how much of each purchase? What we're going to call this, the number of stock A shares and the number of stock B shares, and the variables we're going to associate, the letters I'm going to choose from the alphabet to represent those things that I don't know, will just be A and B. What do I know? We're going to know the prices. The price A was $12.41 a share, and B was $8.62 a share. We also have some totals. You can see the word totals right here. Total 79 shares. Total $825. That's great. So I can use those totals to write equations, and many of these are going to be like in standard form. You can see total 879 shares. That'll be A plus B is equal to 79. Total money is going to be this: the price A plus price B is equal to a total $825. So look for those totals. It's going to show up all over the place. Again, the technique of substitution requires that you have one of the variables all by itself, and we don't have that at the outset, but easy enough to subtract. I shouldn't say easy, not obvious, but the technique here is one step to subtract A from both sides to get B is equal to 79 minus A. So once we know that what B is equal to, we can write the bottom equation, the blue equation, again, and instead of writing B, we can write what B is equal to. Inside a set of parentheses, we get that 79 minus A, and there it is. And the rest is just solving one equation with one known. Often we distribute first, and then combine the like terms. This 12.41a and minus 8.62a gives you 3.79a. And then undo the addition, and then undo the multiplication, and you get A is equal to 38. Studentship tip: in these sections, your particular textbook doesn't usually like to give long repeating decimals as answers. So if you get, and Alex is the same way, alex.com. So if you get an answer of like a long repeating decimal, then I would check your work. Right, so here's the answer: the number of shares, and also the word problem here dictates the fact that like you can't buy a decimal number of shares. You can only buy like 1 or 2 shares. You can't buy 1.5 shares. So that means if you get 38.6429318 long repeating decimal, you better check your work. 38, 41. 38 shares of stock A, 41 shares of stock B, because one of the equations above, B is equal to 79 minus 8, you just put 79 minus 38 here and you get 41. Let's do this again. Chemistry. I know a lot of you sophomores are taking chemistry right now, and so this legit problem came right from the SAT prep. So this is the kind of thing I think this might be one of the harder problems in the SATs. But let's talk about it right now. Maya is preparing a hydrochloric acid HCl solution. She will need a total of 280 milliliters of a 5% solution to use during a lab. If she has 3.5% HCl solution and a 7% HCl solution, how much of each solution would she use in order to make what she needs? Now, this is it shows up in the SATs because this is a problem that is a lot easier to do if you've actually poured these chemicals together. If you've actually done these calculations before, then you can, then the problem just gets a whole lot easier if you have the scientific context. You absolutely 100% need to know one of these equations from chemistry, and you also just have the wherewithal of what to do with all your numbers. It gets a lot easier if you've actually poured them out. So, it's also, the SATs are also testing your scientific knowledge and all that. All right, so unknowns. X milliliters of 3.5% HCl. That's what we don't. You get the unknowns from the question. How much of each solution, there's 2 different solutions, should she use in order to make? So how much is a question, would be measured in milliliters, because we're looking at milliliters right here. We have X milliliters of the one, and the first solution is a 3.5%, and the next one is a 7%. And I'll just call them X and Y. Those are the things we don't know, we're looking for. We find them, then the problem is done, and we report the answers. Knowns. Here's what we do know. We've got this equation from chemistry. If you want, so HCl is actually a solid. Like if you take HCl solution, it's basically water mixed with like these crushed tablets of hydrochloric solid. HCl comes into solid, and you like mix them up, and eventually all of a sudden it's kind of like sugar water, salt water. It's just HCl water. And so how much is there would be like the equation that relates them all together is the mass of the solid. And if you wanted to reverse the process, instead of like, I should say, when you create the HCl solution, you take these tablets, they look like Tums or whatever, and you crush them up, and just like you could salt or sugar, you crush them up into a powder, and then you mix them up, and you get just like salt and water, you could create salt water and sugar water, you get HCl water. It's a solution. Then if you wanted to reverse the process, you could like take the solution and boil it for a while, and all the water leaves off in steam, and then you're left with just this solid mass, like you would if you had sugar water or salt water. Eventually it would just be like coating the glass in salt or sugar, in this case HCl. So that's how you can think of the mass of hydrochloric solid that there is inside of a solution. That mass is measured in grams, just like you could measure the salt or the sugar that you mixed in grams. That the relationship between mass percent and volume is this: percent solution, like the 3.5% or the 7%, times the volume in milliliters. So we need to know this equation in order to construct, you need to know this formula in order to construct our equations. But we do have one total. We know that the total volume is 280 milliliters. Notice the word total is actually absent from the SAT words. It's to make it harder to construct this equation, they don't use the word total. But we can infer that it's a total volume. X plus Y is going to equal 280 milliliters. You're going to pour some, you got two beakers in your hands, and one of them is twice as strong as the other one, and you're going to pour some of each in to a third beaker. X plus Y is going to equal 280 milliliters. That's how much she needs. Now from this formula here, percent solution times volume, we're going to get a total mass. We don't know, it doesn't say exactly how much the total mass is, but the formula says you can take the volume times the percent and get the mass. So this the end result beaker, the total beaker, the final beaker, is going to have 14 grams of HCl in it. It's going to be 280 milliliters in volume, and because I know the percent, I get 280 times 5% gives me 14 grams. It should have 14 grams of hydrochloric, solvent inside of it. And so what we can do is we can come up with a mass equation. This is a volume equation, and now we have a total mass equation. X was, the amount from the volume of the first beaker times its percent plus the volume of this one times its percent will equal the total volume times its percent. This is basically the amount of mass you have in the first one, and the amount of mass you have in the second one, and the amount of mass you have in the third, the total. Now, if you wanted to multiply all these by 100 to clear the decimals or the percents, then you'd get 35x plus 70y is equal to 1400. Boom. I think it's easiest to solve the red equation by to get y all by itself, and so I'm going to take that and plug it into the blue equation right here, as you can see. Then we distribute, then we combine like terms, subtract 2100, and then divide by negative 35 to undo the multiplication. And what you're left with is 200. X is going to equal 200. 200 what? 200 milliliters of HCl. You can plug it back into the red version of this version of the red equation. You get y is equal to 300 minus 200, 100. So there'd be 200 milliliters of X and 100 milliliters of Y, and that gives you what you need. Super tricky, but doable. And if you practice this often enough and you practice your chemistry, then this is the kind of thing that will eventually become a bit more automatic. I'm glad to show it to you now. Tickets. Mr. Jansen paid for admission to the high school football game for his family. He purchased 3 adult tickets and 2 student tickets for a total of $22. Miss Pham purchased 5 adult tickets and 3 student tickets for a total of $35.75. What is the cost of each kind of ticket? There are my unknowns. I'm gonna choose the letter from the alphabet to represent the thing we don't know. What do we know? We don't know the cost of the adult. We don't know the cost of the student. I'm going to let A, B represent this, and S represent that. We got two different totals, $22 and $35.75. And now I'm going to take these numbers and combine them all into an equation that helps me figure out. 3A plus 2S is equal to $22. 5A plus 3S is equal to $35.35. Boom. All right, so we're going to have to get one of these variables all by themselves. I think the easiest thing to do would be to get this S all by itself. It's just a choice that I'm making. You could choose any 4 of these, this A, this S, this A, or this S, but I'm going to choose this one because I think it's easiest. I only get 1 decimal. Dividing all the terms on both sides by 2, you get this, and then subtracting 1.58 from both sides, you get this. And then it's going to be the same technique over again. We're going to take this other equation, the blue one, and instead of writing S, I'm going to write what S is equal to inside of a set of parentheses. 5A plus 3 times 11 minus 1.5A. That's what I had up here is equal to that. We're going to distribute, combine like terms, undo the addition, undo the multiplication, and there we get the price of an adult ticket is $5.50. So then I can take this this version of the S equation and say S is going to equal 11 minus 1.5 times what I know A to be. I figured it out. It's up here. And so I'm going to substitute that in as well. And I get $2.75. Boom, there it is. All right, people. Oh, yeah, we got one more. Oh, so important. Games. The Newton City Park has a total of 11 basketball courts, which are all in use. There are a total of 90 people playing basketball, some in 5-on-5 games and some in 3-on-3 games. How many games are being played? Unknowns. What don't we know? We don't know how many games are being played. There are 10 games with 10 people, like the 5-on-5 games, and the 3-on-3 games have 6 people. So we know there's a total of 11 courts and 90 people. Boom. X plus Y is equal to 11. And then 10x plus 6y is equal to 90. It's the total number of courts equation and the total number of people equation. Let's get y all by itself by subtracting x from both sides. And then you can substitute it into the blue equation. You get 10x plus 6 times 11 minus x is equal to 90. Distribute, combine like terms, undo the addition, undo the multiplication. You get x is equal to 6. Plug it back into the red equation. Y is equal to 11 minus 6. And then you get your answer. And you can present it right here. I want you to figure out what that red dot is covering up and save it for the Edpuzzle, which is coming up right now, y'all. All right. Thanks for staying with me. It's been a blast. Can't wait to see you in class very soon. Until then, take care.